Hi, good day. This is Gary Zassman. If you'd like to learn about Lambda as well as the best practices before you go into coding, you're at the right place. Today we're going to cover a little bit of introduction, what functions as a service is, this paradigm shift from legacy apps to functions as a service, how it's priced, what they are exactly, what triggers them, what the attributes are, and the best practices around functions as a service. So again, as a quick introduction, this is Gary Zassman, and I've been working in SaaS for the last 10 years, and I've been working on a transformation of the FAS system with AWS. And this is why this deck started, as we started looking at the best practices that we would make use of before we implemented our FAS functions. We have multiple pathways we can take with a cloud provider: infrastructure as a service, containers as a service, platforms as a service. But today we're going to talk about the fourth column, which is functions as a service. And as you can see, the service provider you select will take care of just about everything. That's all the functions, from the data center all the way through to the function capability, and you will take care of your application. So you'll invest your time in the application and not in the infrastructure. So this is the paradigm shift between a legacy application and a function as a service application. The legacy application, you have a front end, data backend, and a database. With a serverless function, you have a function as a service for the front end, and then you connect to a bunch of other services, from authentication to account services to database services, etc. With legacy apps, you've got to do significant maintenance as far as patches, updates, and with a FAS, the patch and update system is done solely by the provider. From a legacy app, you pay to provision servers and a 24/7 server team, whereas FAS, you only pay when the functions are invoked, and you leverage your FAS provider. The legacy app, you network using IPs, and with functions as a service, you access them through APIs and URL. Now, legacy apps are best when you have many library dependencies, so large amount of dependencies, and serverless functions that run in containers. They're best with few libraries because the libraries dependencies are packaged with the app. Now, legacy apps, you typically build out a dev test and production environment where the dev test and prod functions are built out inherently in the FAS capability. Now, legacy apps are best for variable execution time greater than 15 minutes, and FAS for execution time less than 15 minutes, as that is the maximum runtime you can have for Lambda today. Now, how do you pay for these services? Well, basically what's happening with a Lambda function, you upload the code, you set your code to trigger, and then when it's invoked, you pay for the time it's invoked. Now, how's that worked out? Well, you've got to figure out the number of requests, the duration of a request, and the memory. So you will select the amount of memory, and the CPU will be tied to the amount of memory. So it starts with small memory and increase as needed so as not to waste any money on this function. Some of the FAS features, so the server-side FAS functions, they look like programming functions. They're small, little units of logic that have taken inputs, arguments, operate on them, and then return a result. They're stateless, so every time you invoke it, you're in a new container with a new disk. So you might want to use external database system or file systems to maintain state. They're also ephemeral in that every time you spin it up, you might be in a new container. Well, you'll definitely be in a new container as they're terminated once the function is run. So FAS is the simplest way to develop. You simply write the function, you upload to a cloud provider, you configure, and then it'll only run when triggered. Okay, so what happened? So you basically want to configure these functions to respond to some sort of event, e.g. a HTTP request or something similar. Or you might even consume an event from a queue or run on a schedule. And the communication is done when the service that you integrated with sends data in a JSON document as an event. Now, these JSON documents will differ for each type of event, and they contain data about the resource and requests that trigger the function. Okay, the Lambda function will convert the event into an object and pass it the function. So then your function handler is the method in your Lambda function that processes this event. And when you invoke the function, the runtime runs the handler method. Now, what events can trigger these functions? Well, you can have services that Lambda reads. You can have synchronous services that trigger Lambda, or you can have asynchronous. Now, in asynchronous functions, you wait for the Lambda function to process the event and return a response. Now, asynchronous is different in that the Lambda queues the event for processing and returns a response immediately. So in the case of a synchronous invocation, Lambda handles the retries and can send failed results to or failed runs to a dead letter queue if configured. Now, these will simply scale out for you. So the stateless function, many stateless functions in containers can be started in parallel based on the load. What is the life cycle of function? So for instance, if somebody accesses your function through the web, the user clicks on a product, for instance, specification, he wants the product spec, creates a web event which is received by an API gateway, the gateway triggers the function. Now the runtime of your function starts. So you download code and dependencies, the container which has all these dependencies and code is spun up, then it's bootstrapped, and then after those three things, the function runs and retrieves that product data from instance, e.g. DynamoDB, and then returns a result. After that, the container is terminated and gone forever. Now, how does that translate into a best practice? Well, if you look at the cold start times, you're going to download code and dependencies, and that's why we asked you to keep those packages as small as possible. You're going to spin up the container and bootstrap before you even start running the function. This is called cold start time. So what can you do about this cold start time if you're concerned about this slowing down your function? Well, you can pick the function to keep it warm. That might cost you money. You control the dependency of package in your deployment package, so make sure you only have the dependencies required and try and keep the size of that deployment package down. And then reuse connections to other systems. That'll optimize the cold start time. Then you also might have a problem with a warm start time, which is the execute function. And this can be optimized by using good coding and as well as interpreted languages like Python. So some more best practices. So from a high availability perspective, make sure you can run in multiple subnets or across availability zones in case one goes down. For IPs, make sure there are enough IPs in each of the AZs so you can spin up more functions. And then pay attention to the concurrency settings. Look at concurrent executions and unreserved concurrent executions. Why? Because this could land up in throttling. So if you exceed a concurrency limit, Lambda starts throttling the offending functions. And what you'll see for synchronous functions, you'll see a 4 to 9. And asynchronous invocations will be sent to a dead letter queue. So you'll check the dead letter queue to see if that's increasing in size. From a cost perspective, you need to optimize your costs. Don't overutilize memory, as CPU is tied directly to that, and turn your costs. And then use CloudWatch to track what's going on with your functions. From a database perspective, make sure your code complies with any best practices you can find on that database and from AWS. So Lambda can freeze any type of variable, which includes database connections, so you can reuse these database connections and also create your connections outside of the function handler. And then you need to consider if you're going to move code to another vendor at some point and how you're going to go about programming this, as you'll be using the provider's API and integrating with their specific cloud services. From a coding perspective, have your business logic outside of the Lambda function, and the Lambda have the handler retrieve the inputs, pass it to the other functions and methods. Monitoring, you're going to use CloudWatch to track all your functions, and you can also set up alarms so that you'll know when the functions are going bad. You can also use that in testing so that you can get alerts on when you're getting errors. You can also use X-ray to visualize the service in conjunction with other services. That's a great way to see what's going on and where the time is being spent in the processing of an event. You can use canary deployments, so have your new code run in parallel and take a small amount of the load until you're happy that it's debugged and running well. From a security perspective, let each function have its own role, IAM role, so you're not giving any function too much capability or too much security clearance. And then from a testing perspective, this is different and difficult, can be difficult. So use CloudWatch, as it will automatically track the number of requests, the duration, as well as the number of requests that have errors. And then you can use AWS SAM CLI. That will enable you to run your application both in the cloud as well as locally in your dev host. Thank you very much, and please support my channel, and we'll be able to share more of the best practices as we research and uncover them. Please go to my YouTube channel and support this channel. You can find it by doing a Google search of Gary Zasman YouTube channel. Thank you, and have a wonderful day.